Hello there, in this video I'm going to talk to you about how to deal with fractional indices. Before you watch this video, you probably want to have already watched my video on unit fractional indices because this video is going to develop and kind of progress from there. So to start off with, what I've got here is I've got a number line, but it's not the kind of number line that you might be used to seeing. This number line you have to multiply to go along the jumps. So for this number line, I start with a 1. We always start with a 1 with this type of number line, because if you start with 0, when you multiply, you're never going to leave 0. So we start with a 1, and I've got 32 at the other end. And I'm going to use this number line to find 32 to some powers of 1/5 or fifths. So in order to do that, what I've done is I've taken the number line and I've split it into fifths. And just to help you out, I've put one of the numbers in one of the gaps. So the first thing I'd like you to see if you can do is figure out what you're going to have to multiply by to correctly get up to 32 in 5 jumps, and then see if you can work out what numbers have to go in these gaps. Okay, so hopefully you've had a chance to have a little think about that. In order to get to 32 in 5 jumps, what you need to do is times by 2 each time. So each of these jumps is a doubling jump. To work that out, if you're thinking what times itself 5 times gets 32, what you're doing is you're doing the 5th root of 32, or what to the power of 5 gets you 32. So now that I've worked out that it's timesing by 2 every time, we can fill in the missing gaps. Again, if you haven't already done this, pause the video and have a go now before I do it. Okay, so timesing by 2 each time, we're going to have 2 and an 8 there and a 16 there. Okay, I can now use this number line to work out the powers of 32 to the fifths. So 32 to the 1/5 is 1/5 of the way along this number line, so 2. 32 to the 2/5 is 2/5 of the way along. So 2/5 of the way along this number line gets us to the 4. For 32 to the 3/5, I need to go 3/5 of the way along. And for 32 to the 4/5, I need to go 4/5 of the way along to get 16. And some of you might have noticed as well that another way of doing this, to get 32 to the 4/5, you can do 32 divided by 32 to the 1/5, which most people don't do because it's more complicated, but technically you could do 32 divided by 2, if you're just wanting to knock 1/5 off. Okay. So that's how to go about this process using a number line. I'm going to do 2 more examples with a number line, and then I'm going to show you a slightly different way of doing it. So I have created 2 more number lines. For this one, I've taken 1 and 27 and I've broken it up into thirds because we're going to use it to do 27 to the 1/3 and 27 to the 2/3. And for this one, I've taken 1 and 625 and I've broken it up into quarters because we're going to use it to do 625 to the 1/4 and 625 to the 3/4. If you can, pause the video, see if you can work out what the timesing jump is, see if you can figure out what goes in those gaps, and then you might even be able to work out the answers to these questions too. Okay, so for the first one, in order to get from 1 to 27 in 3 jumps, we need to times by 3 each time. Okay, so I can fill in the gaps. 1 times 3 is 3, 3 times 3 is 9, and I can check I'm right. 9 times 3 does get me 27, so that's correct. For this one here, if I want to get from 1 to 625 in 4 jumps, I actually need to times by 5 each time. Okay. Sometimes these take a little while to work out, which is fine. You just give yourself time to work out and trial and error if you need to. So 1 times 5 is 5. 5 times 5 is 25. 25 times 5 is 125. And if you did that times 5, you would get up to 625. So now that I've got my number line set up, I can go fractions of the way along in order to work out these powers. So 27 to the power of 1/3 is 1/3 of the way up to 27. So here's the overall gap. 1/3 of the way into that is 3. 27 to the 2/3 is 2/3 of the way in. So 2/3 of the way in gets me 9. For the quarters, again, I'm going to break it up. Here it is. So if I want to get 625 to the 1/4, I'm going to go 1/4 of the way in, which is 5. For 625 to the 3/4, I'm going to go 3/4 of the way in, which gets me 125. Okay, so those are my answers for them. Now, this number line method is great, and if you find this method works for you, then that's brilliant. If what you would like is a slightly quicker method, now that you've seen how it works, I can show you one now. Okay, so here is the alternative way of thinking about it. When you are finding out how many jumps you need, what you're actually doing is a root. So when we were doing here 27 in 3 jumps, I was doing the cube root of 27. So if you will have to do 27 to the 2/3, you can do the cube root of 27. And then once you've done the cube root, you then do 2 timesing jumps along it, which is the same as squaring. So the other way of thinking about this is do the root and then the power. So root the denominator, power for the numerator. Okay, so cube root of 27 and then square it. If you do this in an exam, I would suggest you write that out and then you work out the bit inside the bracket before squaring it. So the cube root of 27 is 3, then we square it and we get 9. And you'll notice that what we did on the number line is we found 3 first of all, which we have there, and then we did 3 times 3 to get the 9, which is there. So it's the same actual process, it's just a different way of showing it, which is fine. So for this one here, the 4 tells us to do the 4th root and the 3 tells us to cube. So I'm doing the 4th root of 10,000 and then I'm going to cube my answer. So 4th root means what times itself times itself times itself gets us 10,000. That's 10. And then I have to cube 10, which is 1,000. Okay, so root then power. That's the way to do it more quickly. But try and get your method written down like this if you possibly can. Okay. Right, here are a few questions for you to have a go at. Once you've had a go, play the video and I will talk through the answers for you. Okay, here we go. So for this one, I'm going to do the cube root of 8 and then I'm going to square it. Cube root of 8 is 2, square that is 4. This one, I'm going to do the cube root of 125 and then square it. The cube root of 125 is 5, square that is 25. For 81 to the 1/4, I just need to do the 4th root of 81, which is 3. Okay. For the next one, I need to do the 4th root of 81 and then cube it. So that is 3 cubed, which is 27. Okay. Next one, I need to do the cube root of 216, then square it. Now, the cube root of 216 might have taken you a while. That's absolutely fine. It's actually 6. And then I square 6 to get 36. And then the final one, I need to do the 4th root of 16, then cube it. That gets me 2 cubed, or 8. Okay. Let's move on to some slightly more complicated ones. Right, so I'm now going to go on to ones where instead of having a normal fraction, we have an improper fraction. It works exactly the same way, and the rule we've seen will work too, but I just want to show you a couple of examples before giving you some to practice. So I've got 8 to the 4/3 here. So on my number line, I've got 1 and 8. I've broken it up into thirds. And because I want to go to 4/3, I need an extra third going on after the 8, which I've put here. So first of all, I need to break the gap between 1 and 8 into 3 timesing jumps. That's going to be timesing by 2 each time. So I'm going to have 2, 4, 8. And then to go to the next position along, I'm going to have 16. So if I break 8 into thirds, and then I go 4/3 up from the 1, I get 16. It's a little bit weird, but it does still work using this number line process if you like it. So 16 to the 3/2, again, I've got 1 and 16. I've broken it into halves because that's the fractions I'm dealing with. And because I need 3 halves, 1, 2, I need to go a little bit further, so an extra half going along there. So 1 to 16 broken up into 2 jumps. Work out what goes there, and then you'll have your answer. So To break the 1 to 16 into 2 jumps, I'm timesing by 4 each time. So I need a 4 here. And then if I carry on an extra jump, 16 times 4 is 64. So 16 to the 3 halves is 3 of those along, so it's 64. Okay. The other method, the method where you do a root and a power, works for these ones as well. So for this one, you can do the cube root of 8, which is 2, to the power of 4, which is 16. This one, you can do the square root of 16, which is 4, cube it, which is 64. And you'll notice those numbers are what we've got going on here as well. Okay. So I'm going to give you a few questions to do on this before we do some slightly more difficult ones just to finish off. I've also put a challenge question at the end of this, if you feel like you want to have a go at that, but don't worry if not, I'll talk it through anyway at the end and you can see if you can follow the process then. Okay then, so for the first one, I'm doing the cube root of 27 and then doing that to the 4. Cube root of 27 is 3, to the 4 is 81. I've got to do the square root of 4 and then cube it. So the square root of 4 is 2, cubed is 8. Next one, cube root of 125, and then that to the power of 4. Well, that's 5 to the power of 4, 625. I'm running out of space here, so I think I'm going to now just talk through the process and then write the answer. But if you did it in an exam, this is the way you'd want to show it. So 32 to the 1/5 is 2, and then I need to do that to the power of 6, which comes out as 64. Next one, square root of 9 is 3, and then I've got to cube it to get 27. Next one, 100 square rooted is 10, to the power of 5 is a 1 with 5 zeros on, so 100,000. Okay, final one, the 4th root of 16 is 2, raise that to the power of 5, gets me 32. Okay, but you just do that step by step. It will take you a little bit longer until you get really, really well practiced with indices. You will notice that as we go through this topic, the same numbers keep coming up again and again. And the reason for that is you're only going to ever really be asked to deal with low powers of 2, 3, 4, 5, maybe the very low powers of 6 and the powers of 10. So if you get used to it and you do a lot of practice, you will find you start recognizing those numbers and become more familiar with them. Right, I'm now going to do the challenge so that I can talk through that one. This is really beyond GCSE. It's just a nice little way of thinking about this question so we can really check we've understood the ideas. So for this question, we've got x to the power of 5 halves has to come out as 32. Two ways of doing this. First of all, if I start with x, what I know I have to be able to do is square root it and then do it to the power of 5 and I end up with 32. So what I could do is basically undo that process. I could do 32 to the power of 1/5 or the 5th root, and the 5th root of 32 is 2, and then the opposite of squaring, sorry, the opposite of square rooting is squaring, so I could then square the 2 and get x is 4. Let's just check that that works going forwards. So if I do the square root of 4, I get 2, and then 2 to the power of 5 gets me 32. So x has to be 4. Another way of doing it, if you are liking the visual method instead, we can do that as well. So 5 halves of x gets me 32. So from 1 to 32, what I would have had to do is, if I had x there, broken x into halves, and then I need 1, 2, 3, 4, 5 halves to go along. So I've got to work out what number goes there on that number line. So first of all, you'll notice we've got 5 jumps going up to 32. So each jump is going to have to be timesing by 2. So if I times by 2 and times 2 again, I will get 4. Okay, so just 2 slightly different ways of thinking about that problem. Right, before I finish this video, I want to talk through one more thing, which is something you see quite a bit at the level 9, so right at the top of the GCSE, right at the end of the paper, and that is when they give you a fraction as the base. It's not as bad as it sounds. Do persevere with it if you get one. Okay, I just want to show you 3 examples of that so you've seen it too. Okay, here are 3 examples of fractions to the power of a fraction. So first of all, this 3/2 means I'm going to square root and then cube. So I'm just going to write that down first of all. I'm going to square root a quarter, then I'm going to cube my answer. Now, to do the square root of a quarter, I'm thinking what times itself gets me 1/4. 1 times 1 gets me 1, 2 times 2 gets me a 4. So the square root of a quarter is a half. So I'm doing a half, and I've got to cube it. So that's a half times a half times a half. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Now, some of you might see that what you could do is just square root and then cube the numerator, square root and then cube the denominator. So square root of 4 is 2, cube it is 8. Okay, so you can just do the power of 3 over 2 to each number one by one. And you'll notice that these numbers will probably start looking familiar to you because, again, they're the numbers that you get from the powers. So I'm going to do this one the long way and then this one the quick way. So you've seen 2 more examples fully. So 8 27s to the 2/3. I need to cube root and then I need to square. So I'm going to write that first of all. Cube root of 8 27ths that I'm then going to square. So to cube root, what I'm asking is what times itself gets me 8 27ths? Well, 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. So the cube root of 8 27ths is 2/3. I then have to square it. So 2/3 times 2/3 is 4/9. Okay, so I get 4/9 as my answer. Sorry, I've not got much room to write that there. Okay, so again, the quick method that you could do is cube root and square each number one by one. So cube root 8 is 2, square it is 4. Cube root 27 is 3, square it is 9. And I'm going to do that quicker method for this one here. So what this means is cube root and then raise it to the power of 4. So the cube root of 27 is 3, which I'm then going to have to raise to the power of 4. The cube root of 125 is 5, which I'm then going to have to raise to the power of 4. 3 to the power of 4, 3 times 3 times 3 times 3, take your time working it out, it's actually 81. 5 to the power of 4, 5 times 5 times 5 times 5, again, take your time working it out, it comes out as 625. So that's my answer for that one. Okay, so it does get quite complicated, does get quite tricky. This is one of those topics where familiarity, lots and lots of practice is going to make life easier for you because the same numbers keep coming out. You'll notice I've got 8, 27, 125 and 4, okay, and 81. The same numbers are coming out again and again and again because those are the numbers that we can get to from low numbers raised to powers. And because it's non-calculator that you're going to get this in, there is a really very limited range of numbers they can possibly give you to work with. So practice really will pay off for this.